Today's problem was submitted by a viewer, and it says, what is the maximum perimeter of a triangle whose side lengths are 5, 5r, and 5r squared, where r is greater than 0? Interesting. Okay. Maximum perimeter. Oops. Don't really need the arrows for this one. This is probably a bad diagram. R is greater than 0, but it doesn't say anything about R being greater than 1 or less than 1. I guess it doesn't really matter, right? Because we could replace R with 1 over R. 5r, and 5r squared. Maximum perimeter. I mean, I guess there's going to be some kind of trigonometry involved in this, like cosine law or oh, hold on a second. Ha! No, there's no trigonometry, but there is triangle inequality. Okay, so I don't know what I was thinking. Oh my goodness, I had a bit of a block there. We don't care about the area of this triangle. For some reason, I thought there was area involved. The perimeter is of course just 5 plus 5r plus 5r squared. The issue here is that there's going to be a bound on r. If as r gets larger and larger and larger, this side length grows so quickly that it will eventually be larger than the sum of that side and that side. And so you can't actually form a triangle with these things. So in some sense, there is no maximum, because for a sufficiently large, as r gets larger and larger, eventually this triangle will actually just be a flat single line with area of 0. But I assume that that's pretty much what they're looking for. So what I want to do is I want to set 5r squared equal to 5r plus 5, because this will determine the largest possible value of r. At least, you know, it's the least upper bound for values of r. So this says that r squared is equal to r plus 1. So r squared minus r minus 1 equals 0. Is this the golden ratio polynomial? I don't know. Let's just, I think it is. But let's just solve this. So r has to be equal to 1 plus or minus the square root of 1 plus 4 divided by 2. We can't take the negative sign, so r is equal to 1 plus root 5 over 2. That looks like the golden ratio. And so another way of doing this. So the perimeter is 5 plus 5r plus 5r squared, but that sum, I'm forcing the sum of these two numbers to be equal to that number. So this is equal to 10r squared, where r is this number. Is there a nice way of writing what that number should be? Let's just simplify this. This is equal to 10 times 1 plus root 5 squared over 4. So we've got 5 over 2 times 6 plus 2 root 5. So that's 5 times 3 plus root 5. Oops. Yeah. So I get 15 plus 5 root 5. And that's the maximum perimeter that that we can have. Yeah, but of course it's as r gets larger and larger and approaches this number, the shape of the triangle becomes a single straight line. So whether you want to call it a maximum or not, this is the least upper bound for the perimeter, which is maybe a slightly more accurate way of stating this question, but I'm sure this is what they're getting at, right? I don't know why my brain went to some kind of trigonometry thing initially. Maybe it's because as soon as I saw that it was a geometry question, I tuned out. Don't particularly like geometry type questions, but this very quickly translates into something which is not geometry, right? That is, of course, the perimeter, but if it's a triangle, you have the triangle inequality. This has to be less than or equal to that. And so, yeah. Okay. Not much more to say about this one, but if I have some kind of mistake, I mean, I might have made an arithmetic mistake in getting this. The approach is correct. As far as I'm concerned, the approach is fine here, but maybe I've made some kind of simple arithmetic mistake down here. But if there's something else that I think of that's incorrect here, I'll let you know. Thanks for the submission, and thanks for watching.